Okay, good morning. Preparation of alkene. Dehydrohalogenation of alkyl halide. Dehydrohalogenation involves elimination of the halogen atom and of the hydrogen atom from a carbon adjacent to the one losing the halogen. Okay, alkyl halide. Alkyl halide is the halogen groups. The connected carbon to the halogen is the alpha carbon, and second one is the beta carbon. Uh, this is the base. Potassium hydroxide is the plus charge, and hydroxide minus charge. Minus charge is the electron density. This minus charge hydrogen is abstracted by this hydroxide and produces the water. But in case of the haloalkane, the halogen have the electronegative. So this carbon is the uh, electron density is lower. So this carbon attracts this electron of the hydrogen and this beta carbon. And also the electron density is uh, reduces. But this halide have the attracted the electron is negatively charged. It attracted by this potassium positively charged, so produces potassium bromide, and the alkene is the produces from 2-bromopropane produces propene by the dehydrohalogenation of alkyl halide. Another one example. Okay, not mechanism. So same example. E2 mechanism elimination reaction and second order. It is the bimolecular elimination reaction where two groups depart simultaneously with the proton being pulled by a base. The base abstracts the hydrogen and the double bond is formed, and the halogen is removed as the halide ion. To complete this E2 reaction, the transition state is formed. Transition state means the previous bonds is breaking and the new bonds are making. In this case, the base and the hydrogen are making the new bonds, and the hydrogen and carbon is going to breaking down the bonds, and also the carbon making the new bonds for the double bond, and the halide ions going to breaking down. This is the transition state and forms the alkene, and base abstract the hydrogen and produces the halide ions. It is the E2 mechanism. The rate of reaction is proportional to the concentration both the reactants. So rate equal to K RXB. Order of elimination is the 3 degree, 2 degree, and 1 degree. E2 reaction is facilitated by the branching at alpha and beta carbon, strong base of high concentration, solvent of two polarity. E1 reaction, the elimination of reaction in which depends on concentration of the substrate only, that is kinetically first order rate proportional RH. The reaction takes place in two steps. First step, it is the rate determining step. The molecule of alkyl halide undergoes ionization to give carbocation. First of all, the alkyl halide, halide ion is removed and the carbocation is formed. Second step, base abstracts the hydrogen and neutralize the positive charge of carbocation to produce the alkene. The base abstracts the hydrogen and produces the double bond. This is the alkene. It's the second step of the E2 reaction. Order of reactivity of alkyl halide 3 degree, 2 degree, 1 degree due to higher number of hydrogen atoms in neighboring carbon atoms. So high chances to attack by the hydroxyl ion in E2 elimination are maximum, leading to maximum reactivity, and 3 degree alkyl halide is the higher reactivity in E1 elimination due to stable carbocation. Okay, third method, SETGF rule, orientation or stereochemistry for preparation of the alkene. It states that elimination of hydrogen atom goes in that direction, which leads to the formation of highly stable alkene, so that alkene always with the higher number of the substituent will form is the major product. 2-chlorobutane, potassium hydroxide, produces 1-butene major, 2-butene, 1-butene minor, 2-butene major. SETGF rule states that elimination of hydrogen atom goes in that direction, which leads to the formation of highly stable alkene, so that alkene always with higher number of substituents will form the major product. In case of 1-butene, that is 1 carbon in right hand side and 3 carbon in left hand side. But in case of the 2-butene, 2 carbon left hand side and 2 carbon right hand side from the double bond. So is the higher number of substituent is the major product according to SETGF rule. Dehydration of alcohol. D means removal. Hydration is the water removal, and alcohol is converted into alkene by dehydration, that is elimination of water molecule. Mechanism. Protonation of alcohol and base abstracts this the hydroxyl group and produce the OH2 plus. Formation of carbocation and OH2, and this hydrogen is moves double bond formation and the water molecule is removed. By dehalogenation of vicinal dihalides, okay, sorry, let's see again. Mechanism, protonation of alcohol. Alcohol is protonated and forms OH2. Formation of carbocation or carbonium ion. Water molecule loses and forms carbocation. Loss of proton to form alkene, and base attacks this hydrogen and produces the alkene. Dehalogenation of vicinal dihalide. D means removal, halogen removal. Dihalides in which halogen are situated on adjacent carbon atoms are known as vicinal dihalides. Vicinal dihalides on treatment with sodium iodide in acetone or zinc in the acetic acid undergo dehalogenation forming alkene. This is the vicinal dihalide. Sodium iodide reacts and produces alkene and iodine. If we treat it with zinc, it produces the alkene. By control reduction of alkyne, when alkyne hydrogenated in presence of platinum barium sulfate produces the alkene. It's also called indoor catalyst. Alkyne produces alkene. Hydrogen gets absorbed onto the metal surface. Alkyne approaches the hydrogen atom absorbs on the metal surface. Alkyne triple bonds reacts with the hydrogen atoms on surface forming the two new sigma bonds producing alkene. Alkyne, the pi calculus, metal have the hydrogen, accumulate hydrogen, it's the absorbed by alkyne, is the intermediate steps and forms alkene. Okay, it's all about preparation of alkene by dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. In case of alkyl halides, E2 mechanism and UN mechanism. And CHF rules for the elimination of hydrogen atoms. In alkyl halides. Dehydration of the alcohols and dehalogenation of vicinal dihalides by reduction of alkyne with metals. By these four methods, we prepare the alkene. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye bye. See you again.